We're going to be covering over the basics of electricity, and in that topic we're going to be looking over what voltage is. Here we can see that this is going to be a voltmeter, so this is a meter that measures voltage. So here is a multimeter that you can measure different things such as voltage, or you can measure ohms, which is resistance, you can measure amps, which is the current, and many more. So these are the two different things that you can use to measure voltage. So in this part 3 video, what are we going to learn about? So in this part 3 video, we're going to learn about what voltage is. And in our part 2 video, we already learned about what resistance is. And in our part 1 video, we talked about what current is. So in this part 3 video, what are we going to learn about? We're first going to learn about what voltage is. Second, we're going to go over a voltage example for more clear understanding. Third, we're going to go over voltage inside of a household. Fourth, we're going to go over the difference between 120 volts and 240 volts, and which one is more safer and which one is better to use in your home. Fifth, we're going to go over what measuring voltage is, or how to measure voltage. And finally, sixth, we're going to be going over the voltage formula. So this is going to be what we're going to be covering in today's video. So first of all, what is voltage? So voltage is a difference in electrical potential energy per unit of charge between 2 points. So as we can see here is we have a circuit, and basically what voltage is saying that it's a difference in electrical potential energy. So where do we get this from? We get this from the cell or the battery. So inside of this diagram, we can see that there's a cell, or sometimes you're going to have a battery, and basically what happens is that you have a positive terminal and a negative terminal. And what happens is that one of the sides is going to have more charges. So for example, if the positive would have more charges, then this side would be moving like this. So the electrons would be flowing like this. So the voltage, the potential difference, basically pushes the electrons to move from one side, from either the positive or from the negative. And all forms of energy, so all types of this voltage is measured inside of joules. And furthermore, a household AA alkaline battery offers 1.5 volts. So as we saw in this diagram, we can see that this battery might be applying 1.5 volts. Some batteries, such as this one, might have 9 volts. Other batteries might even have more. So basically, the greater the voltage in a circuit, the greater its ability to push more electrons and to do work. So the better or bigger battery you have, the more volts you have, the more greater the voltage is, and the more ability you have to push electrons to do work. And furthermore into voltage, so we already know that the voltage is a potential difference. So basically now what is 1 volt? So 1 volt will be equal to 1 joule, so that is how much work is done, divided by 1 coulomb, which is how much electrons flow inside of your circuit per second. So that is how much 1 volt is equal to. And in short term, 1 volt will be equal to 1 joules per coulomb. So now let's go over a voltage example to give a more clear understanding of what voltage is. So here we're going to have this tower image here, and we're going to explain what this is right now. So the larger the tank is, and the greater its height, the greater the water capacity it has to create an impact when the valve is open. So here what we're doing is that we're saying that this is the water tank up here, and you can see that it's on a pretty high level. And what we're saying here is that this is going to be a potential difference. So since this is really high up and the ground here is really low, and all we're going to do is here we're connecting a wire through kind of like a pipe that connects this water from the tank to the ground. And basically what happens is that once you open up the valve from here, you can see that the water is going to rush really quickly, and then you're going to get your current over here, your water over here really fast. And if we compare that to if we had this tank here, which was really low, if we had the tank really low, then you could notice that the water wouldn't be moving as quickly. So here what this is explaining is that the higher you put it, the more potential differences has, which has a more capacity to create an impact when it is open. And the same thing applies to when you have a battery. One side will be greater than the other, so that will push more of the electrons to flow. So if we see in this battery, one side will have more, so let's say the positive terminal will have more push, and then that will push the electrons to flow more freely. So that's just a quick voltage example to give more understanding. And now let's talk about voltage in a household. So let's first go over a AA battery. So a simple AA battery gives off 1.5 volts, and that's how it looks like. A household wall plug. So if you see any plug in your house where you put your charger in, that is usually typically 120 volts. So it'll look like that. An electric stove that you use for cooking is 240 volts, and you can see that's how it looks like. And finally, the high voltage supply. So you can see from the ones that are in our house, the ones that fly across through like this, so these ones. So these supply 400 kilowatts of volts from through here all the time. So you can see that these are some different examples of how voltage is in our household. Now let's see if 120 volts is safer than 240 volts. So first of all, first glance, if you see 240 volts and 120 volts, you can obviously think that 120 volts would be safer than 240 volts, since 240 volts is double of 120. However, doubling the voltage will be double the current, and the potential for getting electric shock is higher. So let's say we go back to our outlets inside of our houses. So those are 120 volts. So if we do get a shock, we're not going to feel that much. It's not going to be that powerful. But instead, if that was doubled, if we had it to 240 volts, then we're going to have a higher chance of getting a bigger shock, which is potentially going to cause some more damage. So that's how 120 volts is a little safer than 240 volts. And here we can see that there's an image that just shows a person getting shocked from the higher voltage. And both 120 volts and 240 volts can be completely safe if it is used appropriately. So even if your outlets do produce 240 volts, if used properly, then it can still be safe and it won't be a problem. And in any case, it is always important to use caution when working with electricity, regardless of the voltage level, even if it's low or if it's high. So that just covers the question of, is 120 volts safer than 240 volts? So now let's go over measuring voltage. So here we can go back from our first image that we saw when we started this video. This is a multimeter, which basically you can measure voltage. You can see here you're able to measure the voltage and many other things as well. So voltage is measured through a voltmeter, and in the circuit diagrams, the symbol for a voltmeter is a circle with the V at the center of it. So you can see it looks like this. So a voltmeter would just be a V with a circle. So now let's go over the voltage formula. So the voltage formula is equal to V is equal to IR. So voltage is equal to the current times resistance. So where V is equal to the voltage, which is measured in volts, in this I would be equal to the current, which is measured in amps, and R is equal to the resistance, which is measured in ohms. And this formula is known as Ohm's law and is described as the relationship between voltage, current, and resistance in an electrical circuit. So if you remember in our part 1 and part 2 video, we saw that the different types of ways that all three of these connect. And for voltage, is just voltage is equal to I times R. And these are all connected together inside of this electrical circuit, which is also known as Ohm's law. So this is what voltage formula is. And that's basically it for this video. So thank you so much for watching this part 3 video, and we'll see you guys in our next electricity video.